Um, which polymer would you say is the most sustainable currently? Oh, what a great question. It's hard. How you define most sustainable? Like, oh, I need to publish it. Okay. Cool. So yeah, which polymer would you say is currently most sustainable? And that's very hard to say. Like I mentioned, polylactic acid is probably the most common polymer on the market today that is bio-derived and biodegradable, but it's not super easy to degrade. Like it still takes some time, so it's hard to say. A lot of the polymers we make are more sustainable. The issue being that compared to a lot of the petroleum-derived ones, they're very expensive to produce. All of the chemical industry is set up to produce petroleum. They've had 60 years at mastering how to do that. So they've refined that technique, and we have to sort of catch up and persuade industry that actually, you know, these materials are currently more expensive, but if you were to produce big plants and optimize the purification of the monomers and the production, it would be a lot cheaper and a lot more sustainable. There's another question here. How do the properties of a polymer compare to those with more ubiquitous polymers, such as polyester? So, yeah, so polyesters are actually a class of material. So we make some polyesters, just meaning they have that ester linkage in them. But yeah, compared to those polymers, better properties is very hard to define because depending on the application, you want different properties. So the properties for the polymer in the soles of my shoes is going to be very different to the properties of a washing up detergent container. You know, different properties, and actually we need to develop a way of having a full spectrum of properties so that we can say, I want to make this product, I want it to have these properties, how do I make that polymer? And so there's actually some really cool research in my lab going on at the moment where they're looking at machine learning to try and unpack that and look at how, if we have a property, we want, what polymer do we need to do and how do we design that? What does that look like? And so this is a really interesting area of the field at the moment, and one that's sort of rapidly developing, because we need to understand this relationship between structure and properties much better. It's very good drawing out a polymer on paper in our skeletal notation, but how that looks, the properties of that polymer, you know, are unpredictable until you make it. Okay, lots of questions coming in. What do you think would be the limiting step in your perfect pentagon of polymers, i.e., e.g., finding such growing raw materials take too long, providing sustainable polymers for the masses? Yeah, this is a fantastic, really good question. So you sort of touched on that. Things take a while to grow, which is one issue, but also if you are relying on like I touched on, limonene is a really exciting monomer, comes from oranges and lemons. If we become very dependent on that, do we start then diverting production of food towards polymers? And does that drive up the price of food and have a whole range of socioeconomic impacts, which are very hard to predict? In terms of what I think the limiting step will be, I think it would be the actual production of the polymer. Convincing industry that these are materials that they should be interested in and scale up is a very difficult challenge, because these companies, these big polymer companies, say they're doing everything to, you know, be sustainable and developing new plastics, etc. But actually, they have stock, they have shareholders, and they need to produce a profit. And I guess recently, the price of petroleum is going up and up, but typically it's really low. And producing polyethylene, PET for plastic bottles is really cheap. And so convincing industry to say, oh, we're going to stop what we've been doing for 60 years and do this whole new thing that's very risky and expensive, is a hard sell to make. And one that I think will happen, but I just hope it happens soon enough that we're not sort of too late down this road. I hope that answers your question. That was quite a waffling answer, I realise. And I think that's all the questions so far. So it's a great talk. Thank you very much. That's very kind of you to say. I think that's all. So if there aren't any more questions.
Yeah, if there's not any more questions, then on behalf of everybody, can I thank Kam for such a brilliant talk? You know, I thought clearly Charlotte and you and everybody in the Williams group are doing amazing work at trying to make these a bit more environmentally friendly, and keep up the good work, basically. Oh, actually, another question is just pumped in, so I'll just publish that for you.
Thank you. So how hard it would be to integrate the mechanical processes used in this holy grail process in place in countries with limited access to the technology? So yeah, this is the billion-dollar question, really. Difficult is the short answer, I think. These processes haven't been scaled up at all really yet, so that needs to happen first. Actually, there's a company that a polymer company that partly funds my research who are very interested in these materials, and they're doing lots of research on them, but then getting them scaled up is the key challenge. It's doable. It really is doable. It's just a question of when it will be done at this scale. And I think the question is really interesting about in countries where there's limited access to this technology. I think there needs, with all sort of solutions to pollution and climate change, there needs to be a global effort to share resources, share technology, to make this accessible and make this a solution that benefits the whole world, not just a particular few countries. Yeah, really interesting question. Thank you. Is CO2 polymer expensive? Would it be affordable in low-income countries? So actually, there are CO2 derived polymers already available to buy at the moment, typically in quite niche areas. But yeah, so polycyclohexene carbonate is quite a common one. They're not very widely used. I don't know how expensive they would be. And it kind of depends on context, but the key issue being that they're all over the world, they're more expensive than petroleum-derived polymers, just because they can't be produced on the same scale. And even though CO2 is super cheap, it is the that really is holding it back. And like I was touching on the last question, hopefully that will be remedied in time as companies do bite the bullet and say we're going to make this on a big scale.